Okay, welcome student. Here we'll discussing with the part 6 of this chapter 2 on the problem number 8. Find a quadratic polynomial whose zeros are given below. Number 1, 2 by 3 minus 5 by 7. Okay, what are these? These are the zeros of a polynomial. Okay, to find out a quadratic polynomial we need the sum and product of zeros. Okay, now let us find the sum of zeros. Sum will be 2 by 3 plus minus 5 by 7. Okay, now plus minus is minus. Okay, now 3 with 7, LCM of 3 and 7 is 21, isn't it? 21 divided by 3 is how much? 7. 7 multiply with 2, 14. Plus minus is minus. Now again 21 divided by 7 is 3. 3 multiply 5, 15. We have plus 15, plus 14 minus 15. Plus minus is minus. That means we have to subtract these two. 15 minus 14 is 1. Which sign is greater? Plus or minus? Is minus. Okay, now let us find with the product of zeros. 2 by 3 multiply with minus 5 is 7. You'll get minus 10 in the numerator, 21 as denominator. Thus a quadratic polynomial from the given sum and product of zeros will be, you just substitute in this formula for a quadratic polynomial. X square minus sum of zeros plus product of zeros. Sum is how much? Minus 1 by 21. Product is minus 10 by 21. Here minus with minus is plus 1 by 21x plus minus 10 by 21. Okay, now what you'll do here, you multiply throughout the equation by 21. 21 multiply x square, 21x square. 1 by 21x multiply with 21. 21 get cancelled, we'll have only x, and same here also. 10 by 21 multiply with 21, you'll get only 10. Clear? Second one, minus 5 minus 7. These are the given zeros. Let us find the sum. Minus 5 plus with minus 7, plus minus is minus. Minus 5 minus 7 is minus 12. Product of zeros, minus 5 multiply minus 7, minus multiply minus plus 5 multiply 7, 35. Thus the quadratic polynomial form from this given zeros will be x square minus sum of zeros, sum is minus 12 and product is 35. Here minus with minus is plus, you will get 12x plus 35. This is the quadratic equation form out of the given zeros. Clear? The third one, the given zero are 3 plus root 5 and the order is 3 minus root 5. Let us find out the sum. 3 plus root 5 plus with 3 minus root 5. Root 5 will cancel. One is plus, order is minus. They will get cancel each other. And then we have 3 plus 3, that is 6. Okay, now let us find the product. 3 plus root 5 multiply with 3 minus root 5. Just by looking at this, it is in which identity? A plus b, a minus b. What is a? A is 3, b is root 5. Identity is a square minus b square, that is 3 square minus root 5 square. But 3 square is 9, root 5 square is 5 only. Okay, why? Because this radical sign is having order of the radical is 2, power is 2, therefore radical sign can be removed. We'll have only 5. Now 9 minus 5 is how much? Is 4. Thus the quadratic polynomial will be x square minus sum is 6, x plus product is 4, that is x square minus 6x plus 4. Clear? Next we have on the problem number 9. If alpha and beta are the zeros of polynomial px equal 3x square minus 2x plus 6, then find the value of 1 by alpha plus 1 by beta. Okay, now how you'll find? Okay, here I've given you the solution. Let us see how I've done the solution for you. It's given that px equal 3x square minus 2x minus 6. What is a here? A is coefficient of x square, which is 3. B is coefficient of x, which is minus 2. And c, it is minus 6. Then the sum of zeros will be alpha plus beta, which is minus b by a, isn't it? Sum of 0 is minus b by a. That is the formula. Then what is b? Minus of b. B is minus 2. What is a? A is 3. Minus multiply minus plus, that is 2 by 3 is the sum. And product is c by a. What is c? Minus 6 by 3, that is minus 2. Now what we need to find out? 1 by alpha and 1 by beta. Let us take this. We have 1 by alpha plus 1 by beta. Now you take the LCM of denominator, alpha and beta. The LCM will be alpha beta. Now alpha beta divided by alpha, you will have beta. Beta multiply numerator, which is 1, you will get beta. Beta multiply 1 is beta. The same thing, alpha beta divided by beta, you will get alpha. Alpha multiply 1 is alpha. Now beta plus alpha, what it is? Beta plus alpha. Beta plus alpha is the sum of zeros, isn't it? Beta plus alpha or alpha plus beta is the same thing. Alpha plus beta, which is the sum of zeros. How much we have got? 2 by 3. Okay, alpha plus beta is 2 by 3. Alpha beta product is minus 2. Okay, you substitute the sum and product here. Now 2 by 3, you change this division sign to multiply. Minus 2 by 1, isn't it? Denominator of minus 2 is 1. Minus 2 by 1. When you change to multiply, it'll be 1 by minus 2. 2 will get cancelled. You'll get minus of 1 by 3. That is the value of 1 by alpha plus 1 by beta. Clear? The second one, alpha square plus beta square. The same with same polynomial given 3x square minus 2x plus 6. Okay, here the same thing, a is 3, b is minus 2, c is minus 6. Let us again find out the sum of 0. Minus sum of 0 is minus b by a, minus of minus 2 by 3, which is 2 by 3 as we have discussed, and the product of 0 is c by a minus 6 by 3, which is minus 2. Okay, these two we have just find out in the problem 1. Why we are doing again this one? Because in exam they will not ask two problem at a time. They will ask only once. Okay, they ask only once. That means the step you have to follow, whether it's first or second, we have to follow the step. You have to find out the sum of zeros, and then you have to find out the product of zeros. After finding the sum and product, you'll find the value of alpha square plus beta square as being as in the question. Okay, now we need to find out alpha square plus beta square. Okay, alpha square plus beta square. I just look on right side. I've written down the identity for you. A plus b holding square. What is the expansion of a plus b holding square? It is a square plus b square plus twice ab, isn't it? Sometimes we are writing a square plus twice b plus b square. Same thing. What you need a square plus b square. If you need a square plus b square, then a plus b holding square, this twice ab you transpose to the left side, will be a plus b holding square minus twice ab will be a square plus b square, isn't it? Or we can write a square plus b square is equal a plus b holding square minus twice ab. Clear? Now we need alpha square plus beta square. Alpha square plus beta square can be written as, just follow this identity from here. It can be written as a plus b whole alpha plus beta holding square minus twice alpha beta. Clear? Now why do we need to write in the form of alpha plus beta holding square minus twice alpha beta? Because the value of alpha plus beta we have found out, and alpha beta is the product of zeros, which is minus 2. Just substitute the value from above here in this equation. Alpha plus beta holding square, that means sum of zeros, square of that. Sum of 0 is 2 by 3, square of that, minus twice alpha beta. Alpha beta is minus 2, that means minus twice multiply with minus 2. Then 2 square is how much? 4. 3 square is how much? 9. 3 square is 3 multiply 3. Then here minus multiply minus is plus, that is 2 multiply 2 is 4. Now again here we have to find out the LCM. Below of this 4 is 1. 9 and 1 LCM will be 9. 9 divided by 9 is 1. 1 multiply the numerator, which is 4, will be 4 itself. Plus, now this LCM divided by denominator, which is 1. 9 divided by 1, you will get how much? 9. Then that 9 multiplied to the numerator, which is 4. 9 multiplied 4 is 36. Now 4 plus 36 will get how much? 40 by 9, isn't it? Therefore the value of alpha square plus beta square is how much? 40 by 9. Clear? Next, with alpha cubed plus beta cubed, the same thing here. Since the polynomial is the same, we have to find out the value of alpha cubed plus beta cubed for the same polynomial. Here a, b, c is the same as we have discussed. The sum of 0 is also will be the same, that is 2 by 3. Product also will be minus 2, the same. We need to find out alpha cubed plus beta cubed. Okay. Now alpha cubed plus beta cubed, how you'll express this as the sum and product of zeros. Alpha plus beta, alpha beta. Okay, we need to express this alpha cubed plus beta cubed in the form alpha plus beta, alpha beta. Why? Because alpha plus beta we have only found out to be 2 by 3. Alpha beta is minus 2. Now how we'll express this alpha cubed plus beta cubed in the form of alpha plus beta, alpha beta? We will again refer to the identity a plus b holding cubed. A plus b holding cubed, the expansion is a cubed plus b cubed plus 3ab a plus b. Okay, sometimes we are writing a cubed plus 3a square b plus 3ab square plus b cubed. Sometimes we are writing in this form also, but both of these, they are the same expansion of a plus b holding cubed. Now what we need cubed, a cubed, b cubed. We need a cubed, b cubed. What we'll do, you will transpose this 3ab a plus b to the left. That means a cubed plus b cubed will be a plus b holding cubed minus 3ab a plus b. Just substitute alpha and beta here. Alpha cubed plus beta cubed will be alpha plus beta holding cubed minus 3 alpha beta, alpha plus beta. Just using that identity, alpha cubed plus beta cubed will be alpha plus beta holding cubed minus 3 alpha beta, alpha plus beta. Now alpha plus beta is how much? 2 by 3. Just substitute that value here. 2 by 3 holding cubed minus 3 multiply alpha beta. Alpha beta is how much? Minus 2. Multiply with alpha plus beta. Alpha plus beta is how much? 2 by 3. Now from here 3 you will cancel. Okay, now 2 cubed is how much? 2 cubed is 2 multiply 2 multiply 2, which is 8. 3 cubed, same thing, it will be 27. Now this minus with minus will be plus, remaining only 2 with 2, that is 4. Same thing, you will find the LCM of 27 and 1 below 4 is 1. 27 and 1 is 27. 27 divided 27 is 1. 1 multiply 8 is 8. 27 divided by 1 is 27. 27 multiply 4 will be how much? 27 multiply 2 is 54. 54 multiply 2, 108. This means 27 multiply 4 will be 108 plus 8 will be 116 by 27. Clear? This is the end of the part 6, and on the next class we shall discuss with you on the part 7 of this chapter 2. For the time being, we'll conclude it here and continue again on our next class. Bye to all of you.